Hi everyone. This is the video for discussion section 8 of CBE40 for spring 2020. As all of you of course know, we're not having in-person meetings as a precaution because of the coronavirus going around. So we are attempting to do online discussion sections. We've decided to just record these discussion sections and post them for you to watch on your own time whenever it's convenient for you. We know a lot of you might be traveling home or dealing with a lot of other stuff right now. So this is what we've decided to do for now. We've never done it this way before. So please, if you have any feedback or this isn't working for you or there's something wrong, please talk to us. We are kind of also figuring this out as we go along, and we really want it to work as well as possible for all of you guys. There are two videos for this discussion section. There's this one, which is going over the sort of course content for this week, which is economics and how that applies to process analysis and design. There is a second video that will also be posted around the same time that I've recorded that is going over the midterm exam. So please check out that one if you have questions about the midterm or want to see it solved. One of the things that's really missing for online discussion section is, the actual discussion, you guys asking questions and solving through problems. So please don't hesitate to still ask questions. So we have Piazza for you to ask questions if you think it's a possibility that other people might have a similar question. But also, if you have if you're not comfortable with that, although you can ask anonymously, so I hope that you will, but if you have a question that's more individual to you or you feel like you need more help, please email me, that is fine. We are gonna do our best to be flexible with this. Okay, so the logistics are we're going to go over economics today. The one additional thing I would say is please fill out the mid-semester feedback form. It's on B courses. I think it's actually under quizzes, but obviously it will not be graded. It's totally anonymous. But it really, really helps us figure out what you need. Are we going too fast? Are we going too slow? Can you read the chalkboard? Not that there is a chalkboard anymore, but that is really helpful to us. So we can make this course better for you in the second half of the semester. So please, it's like 5 questions. We'd really appreciate it if you take the time to do that. Okay, so economics. There are a lot of definitions here that are important for this. These slides, as always, these slides will be posted in addition to the video. So you can download these. So revenue is in units of dollars per year. So that is typically, as chemical engineers, because we are producing some chemical product and we are selling it. And so it is how many kilograms are we selling per year times how much money do we make per kilogram. Depreciation comes up a lot. So that is also in units of dollars per year. It is our capital costs. So capital costs are one-time expenses like installing the reactors. How much does our separator or reactor cost? Divided by the equipment lifetime. So if we have a reactor that costs $10,000 and the equipment lifetime is 5 years, then we would have a depreciation cost of $2,000 per year. So that's basically accounting for that reactor we bought is sort of losing value over time. Our operating costs are also, again, in units of dollars per year. So those are our annual expenses like labor or electricity, natural gas, whatever, how much, reactant do we need in our reaction, plus depreciation. So basically operating costs are the total amount of stuff that is in the negative per year. There's the stuff you actually spend per year, and then the depreciation. And then profit is just revenue. So how much money are you having come in every year minus the operating costs. And then the last thing that comes up a lot is return on investment, or ROI, and that's in units of percent per year. So that is our profit every year divided by the total initial capital cost. So this is saying if I initially invest $1 million to build my chemical plant, and my profit each year is $100,000, then each year I have a 10% return on investment. So it'll take me 10 years to fully make back up that investment that I had initially made. The last thing that comes up sometimes is equipment scaling cost. So what this is getting at is how much does a reactor cost? And so if I know that my 100-gallon reactor costs $100, then, sorry, my 100-gallon reactor costs $100, then how much will my 200-gallon reactor cost? This is sort of an equation to let you solve for that, where K is almost always 1, and if it wasn't 1, we would tell you what number to use. Where this 0.6 factor actually comes from is that generally with reactors, the cost scales with the surface area, where the capacity is obviously the volume. So if you plug in the equation for the surface area of a sphere and the volume of a sphere, you get a 2/3 power in there. So that's where that comes from. But we would typically give you sort of what fitting equation we want to use, but you should be comfortable sort of given an equation like this, plugging in the capacity of the reactor that you need and figuring out how much that would cost. So these are the definitions of interest. One thing that I would caution you on a little bit is, this is how we as chemical engineers define all of these things. I know at least a fair number of you are getting minors in econ, or at least have taken an econ class. These definitions might be a little different than what you use in those classes. Particularly return on investment, you can find a bunch of different definitions on the internet. So this is the one that we want you to use for this class. So just be a little cautious with that. One of the things that will be uploaded with these materials is a handout that has all these definitions on it as well. Okay, so our first problem, which if we were in a normal discussion section, we have 2 problems. I am going to solve this one for you, and I would make you do the second one in groups. I'm just going to solve both of them for you this time. If you feel really good about this material and you want to just pause this video and use this problem as a practice, you are more than welcome to. If we were in discussion, like I said, I would be solving this one on the board, and I would have you guys practice the second one by yourselves. So I am going to solve this one for you all now. Oops, there's the solution, sorry. Okay, so we have formed a small company to produce the specialty chemical Z. We can produce 100 kilograms of Z per year if we're operating at 40 hours a week. And we're told our capital cost is 1.5 times 10 to the $5, which includes everything, installation, everything else. And the equipment has a lifespan of 5 years. And we're given our operating costs, so $40,000 per year for rent and taxes and everything else, our salary equipment, our salary information, and then our variable costs are $400 per kilogram of Z that's produced. So that is how much, our reactants or anything else that is scaling by how much Z we are producing. So we have two situations. The first one where we have 3 employees needed, and then we want to know what is the selling price for our chemical Z that will yield an ROI of 20% per year. And then in our second situation, we've increased our production by adding more employees, and we again need to find the selling price for that situation. Okay, so I don't have an iPad where I can write stuff, so I am going to use a Word document, and we're going to hope that this is legible for you guys. Okay, so I have the problem statement over here on the left. So the first thing we need to do for part A is we find our operating costs, and that is our $40,000 a year for rent and taxes that they've given us as our fixed cost. We have our own salary. We've given ourselves a very generous $120,000 per year. We have 3 employees, each making a total of $55,000 per year. And then we have our costs of $400 per kilogram. And we're told that in our initial situation, we are making 100 kilograms per year. And then the last thing we have is our depreciation. So we are told that our initial capital cost is 1.5 times 10 to the 5 dollars per year. And we're going to divide that by 5 so that this is all in units of per year. So that is our lifetime. So each year we're losing 1/5 of that capital cost. And so we get a total operating cost of 3.95 times 10 to the 5 dollars per year. Okay, so our profit is whatever our price is. So I'm going to leave that as a variable because that's what we're solving for, times 100 kilograms. So we're going to get a price in units of dollars per kilogram. So we need that kilogram to come back, minus our, so this all equals profit, sorry. So profit equals price times 100 kilograms minus our operating costs. So our operating costs of 3.95 times 10 to the 5. Okay. Our ROI, we know, is our profit divided by our capital costs. And that is on top 100 times price minus 3.95 times 10 to the 5. And then that is our profit, and we're going to divide by our capital cost, which is 1.5 times 10 to the 5. And we know that that whole thing, our ROI, is equal to 0.2. So now we have this equation. So our profit, 100 times price minus 3.95 times 10 to the 5, divided by our capital costs, 1.5 times 10 to the 5 equals 0.2. So we can solve for that and get that our price equals $4,250 per kilogram. Okay, so what we're going to do for part 2 is I'm just going to change part A to part B and change what we need to change. So our operating costs, we still have our $40,000, that doesn't change. Our payroll, however, does change, so we stay the same. Our initial 3 employees stay the same, but we're also going to add 3 more employees which, like it says, are each making 25% higher than the day shift employees. So we're going to do 3 employees times 1.25 times our day shift employees price of $55,000. We're also going to change our operating costs, our variable costs. So we're now making 200 kilograms, so we need to change that. And that is all that's going to change in our operating costs. So that will get us a final operating cost of 6.41 times 10 to the $5 per year. Our profit is the same idea as before. We're making 200 kilograms now, and our operating costs have changed. So they're now 6.41 times 10 to the 5. And then we just need to plug those changes into our ROI equation. So we have our price that goes here, our profit, sorry. Our initial capital cost stays the same. And so now if we solve this modified equation, we get a price of $3,360 per kilogram. So by adding those night shift employees and running more hours and making more of our product, we're now able to lower our price to get the same ROI, or I guess alternatively, keep the same price and get a bigger ROI if that's what you had wanted to do. Okay, so going back to our PowerPoint, the solution to that is written out here in the PowerPoint. Okay, so our second problem is on a handout, though there's a document also on the B courses page. It will probably be called Discussion 8 handout, very creatively. It's the same handout that I mentioned earlier that has all those definitions on it. It also has this problem, so it's kind of a long problem. So it may be easier for you to look at that than to look at my screen. So we have 2 schemes. So this problem, if I was having a normal section, would sort of read the problem to you guys and have you work in groups to try to solve it. I would recommend you sort of listen to my explanation of the problem and pause the video and try to solve it yourself. So do with that what you will. So the problem is we have 2 schemes for producing 100 kilograms per day of chemical P from reactant A, where A is available as a mixture with an inert substance, where we can't easily separate those A from the inert. So there are 2 possibilities. One where we have our A and our inert being fed, we have our reaction, we get our product P, and we throw away all of our A and our inert. The second scheme has that A and inert. It goes into our reactor, our P comes out, and then we recycle our leftover, or we recycle some of our leftover A and inert. So the second part of the problem is on the next page. We have a lot of information. So we have the selling price of P, which is $131 per kilogram. We have a cost of our mixture of A and inert. We also have a waste disposal cost. So when we go back to this process, you can look at how much waste you're disposing. And so now you know how much it costs to do that disposal. We're assuming our process operates 300 days a year, and we have a straight line depreciation. So the math part of the problem is to complete this table. So you're given the reactor cost and the separator cost. So you'll notice that for scheme 2, because you have this recycle stream, everything needs to be bigger, so everything costs more money. We have our natural gas costs, which are different in the 2 systems, our electricity cost, and our wages. So what we need to figure out is our capital cost, our revenue, our operating cost, our profit, and our ROI. And then our second part is choosing which scheme is better based on those calculations that we've done. So this is the point that I would recommend that you pause and try to solve this. If you need a hint, I will sort of show you the start of my setup in a second. Okay, I'm going to assume that you either are done or you need a hint. You have paused this video and tried for a while. So my hint is that the way that I have set this up is I've chosen to solve it in Excel. Again, I don't have a Blackboard, so this is kind of my best option. If you wanted to solve it on paper, that is totally fine. So my hint is that this is an Excel spreadsheet that I have sort of modified the table that I need to fill out, and I've added extra lines. So I've added the information in Excel form. So I have how much I can sell. Sorry, this should not be in the form of dollars. So this is how many kilograms per day of P I'm making, how much I can sell it for, how much my A and inert mixture costs, how much my waste disposal costs, 300 days a year, and my lifetime of 10 years. And then this information is all given in the table that they showed us. I've also added these two pieces of information that I've just read off of the problem statement. So I have how much A and inert I need. So it's 2,000 for this scheme and 1,300 for this scheme. And how much P I'm making is 100 for both. But then how much waste I need to pay to dispose of is 1,900 for scheme 1 and 1,200 for scheme 2. So if you were stuck, maybe making this table will help you. And I will sort of recommend that you pause again and try to solve it if you were indeed stuck before. This is that handout. I'm just going to pull up the problem statement over here so it's a little easier than PowerPoint. Okay, I'm going to assume that you have paused and solved it. So now I'm going to go through my solution. So my capital cost is just the cost of my reactor and my separator. So that is this cell plus this cell. So that's my capital cost for scheme 1. And I can drag this over, and my capital cost for scheme 2 is these two cells for that scheme added together. Okay, so my capital cost is done. My revenue is my production per day times the number of days per year. So I want all of this in per year. So I'm making 100 kilograms per day for 300 days. And then how much money I'm making off of that is $131 per kilogram. So this gives me a revenue, and that's going to be exactly the same in the other system. So we have the same revenue because we're making the same amount of P in both systems. The operating costs are a little more complicated. There's a lot of stuff in here. So our operating costs are going to be our natural gas plus our electricity plus our wages. And now we need to take our capital cost and divide it by our lifetime in years to get our depreciation. We're going to take how much A we need per day. So that's 20,000 times the number of days times the cost of the A inert mixture. And then the last cost is our waste disposal. So we're going to have our waste disposed in kilograms per day, again times the number of days, again times the cost of waste disposal. So that's going to give us our operating cost. And one thing for Excel is if I just drag this over right now, it's going to apply now this number to the second row, but it's also going to try to read this as a number. So if I put $signs in front of the things that I do not want it to change, it will keep those the same. So I'm just going to add, $signs so that when I drag this over to apply to my second row, it will work. Okay, so I'm dragging this over. And so now my scheme 2 is using all of the correct cells, so it doesn't have any of the scheme 1 cells. So we can see that our operating cost is higher in scheme 1 than scheme 2. Our profit is just our revenue minus our operating cost. Okay. And then our ROI, which you might notice I've chosen to format as a percentage, so it just sort of does that for me, is going to be my profit divided by my capital cost, which I solved for here. So my ROI for my first scheme is 57%, and for my second scheme is 41%. So I can, if I want to, modify my sig figs and show only the 2 sig figs. Okay, so we've filled in this table. We have our capital cost, revenue, operating cost, and profit, and ROI. And now we need to decide if we own this process, which scheme would we choose? And so, well, if you want to pause it and think about it, the parameter that you should care about here is return on investment, because our capital costs are different in our 2 systems. So, you know, our profit is higher in our second scheme, but our capital cost was also higher. So the ROI is what lets us say, if we had invested the same amount of initial capital in this, scheme 1 would actually be better. So the answer here is that you should choose scheme 1 because it has a higher return on investment, and that's the parameter that you care about the most. So I will post that spreadsheet. I will post it with the solutions here, and I will remove my solutions from this one if you want to try to solve it using Excel. And the handout will also be posted. On these slides, it has sort of a worked through non-Excel solution that gets you the same number in the same way, but it has, you know, more words. So it has sort of more of an explanation of where those numbers came from. So definitely use those slides. So we have the capital cost, the revenue, reactant cost, disposal cost, depreciation, all of that added up to get our operating cost, our profit being our revenue minus our operating cost, and the ROI being profit over capital cost. So this is scheme 1, and this is exactly the same work, but for scheme 2. So this is the completed table, which is the same as the table I showed you in Excel, but minus the extra rows that I added that I found useful as I was doing my work. Okay, so that is all for this discussion section. I hope that it was useful. Again, I hope that if there were problems and, you know, you couldn't hear me or, you know, whatever, I hope you'll let us know, because we are also still just trying to figure out how best to do this. So please let us know if there's anything we could do to make this clearer. Okay, that is all for this video. You can see the second video for the midterm solutions as well. Okay.